Hi everyone, my name's Jeff Dean and I'm Math Dad. I'm here to help you help your kids understand math. Today we're going to start to tackle one of the most challenging topics in math from kindergarten all the way through high school. And that is fractions. Just the word fractions makes some people go, ugh. I've heard it all my career. Oh, I hate fractions. I could never understand fractions. Just the heads drop and the anxiety level goes up when we start talking about fractions. But I'm going to tell you, if you're a parent and you're trying to help your kids, the best way for you to help them is for you to learn it yourself. So we're going to start talking about some different concepts of fractions that will help you determine whether or not your kids have a good, solid understanding. We're going to start with something simple today, and that is the difference between a whole and a part, and how we want our kids to be able to go back and forth between a whole and a part. Here's an example. Suppose I have something that looks like this, and I say this represents one whole object. I want to know how big this one piece is. Well, if they have a solid understanding of the relationship between a whole and a part when it comes to fractions, they'll be able to look at this and go, since there are 1, 2, 3, 4 equal-sized pieces, that means each one of these pieces is called a fourth. That means they understand that it takes 4 of these things that we call a fourth to make up the whole. So if I say this is the whole, and your students can see it's partitioned into 4 equal pieces, therefore each of these pieces is called 1/4, they have an understanding of the size of the whole to the part. But there's another way to think about this. Imagine I told them that this right here is a third. This is 1/3 of something. How big is the whole? Well, they should be able to visualize or create the whole. This isn't the whole because we said this was 1/3. So it shouldn't just take 2 of them to make the whole. It should take 3 of them. The whole is this big. I gave you the part, and you can create the whole. There's all kinds of ways that you can check to see whether your kids understand that. Here's a piece of chocolate. And you can say, if this is the whole, how big is the part? They should be able to say, if this is the whole, there's 3 equal-sized pieces, so each one of those is 1/3. Then you can get a little tricky because that's not how big these candy bars typically are. Typically, they're more like maybe this. And you can say, well, what if this is now the whole? Well, that thing that was a third when it was just this, if this is now the whole, they would have to be able to say, well, now it's 1/6 of this because the whole now contains 6 equal-sized pieces. And if you want, I got a little hungry, so I ate the other half of the chocolate bar. But if you want, you can add the rest of the chocolate bar. And you can see if they can say, you know what? Each of these pieces is just 1/12 of the whole chocolate bar. It's just a way of seeing whether or not they have a solid understanding of this relationship between a part and a whole. We want them to be able to tell us how big the part is if we give them the whole, or how big the whole has to be if they know the size of the part. Let's look at just another example. Suppose I have this piece here, and I tell you that this is 1/5. A student who has an understanding of what we're talking about here should be able to tell me, if this is 1/5, then this is now 2/5, and this is now 3/5, and this is now 4/5, and I need one more to get 5/5, which is my whole. And if they're saying what I was just saying, 1/5, 2/5, 3/5, 4/5, 5/5 makes the whole, they're starting to also grasp the fact that 5/5 makes a whole, or 4/4 makes a whole, or 3/3 makes a whole, because they have an understanding that the number of pieces that is required is the same as the size of the piece. 1/5 requires 5 pieces. 1/4 requires 4 pieces. 1/3 requires 3 pieces. So my challenge to you is look everywhere. If you see things that are partitioned, ask your kid, hey, there's something that's partitioned. If this is the whole, can you tell me how big each of those pieces has to be? Or if that piece right there is just 1/3, how many pieces does it take to make the whole? And you can even get tricky to really see whether they'd understand. For example, suppose I take this and I tell them that this, I say, the whole is just this much, and then I put this back on here. So I'm telling you the whole just goes to here. But there's these extra pieces on there. They should still be able to tell you that if the whole is just to here, there's 1, 2, 3 pieces in the whole, so it's 1/3, 2/3, 3/3 that makes the whole. And if they really got it, they can keep going, 4/3, 5/3. But I have a whole. The 3 pieces makes up the whole. So you can get tricky. Imagine that you're sitting, I don't know, you're waiting in the grocery store line and you look down at the floor and there's the tile and it's all in squares, and just ask your kids, hey, if this one tile right there is 1/5, can you show me with your feet or with your hands how many tiles makes a whole? There's tiles everywhere. They're actually going to have to pick out the 5 tiles of all the tiles to tell you. Or you could tell them, hey, if this big piece right here is a whole, how big is each tile? And they should be able to tell you, oh, that's a 4th, or that's a 5th, or that's a 1/3. That is going to tell you whether they have this basic concept of fractions. But it's so huge because if you don't understand this piece, it makes it really difficult to move forward in fractions. So that's the challenge. Look everywhere. Things are partitioned everywhere. You'll see shapes everywhere. And when you start to look for it, you will see fractions everywhere. That's the challenge. I'm Jeff Dean, and I'm Math Dad.